All right, guys, we're here, lesson 4.3, revisiting proportional relationships. So, going back to unit 2 stuff. So the I can statement, I can use a table of 2 rows and 2 columns to find any unknown value in a proportional relationship. And when there's a constant rate, I can identify 2 quantities that are in a proportional relationship. So, if we look at 3.1, recipe ratio on page 23, it says a recipe calls for 1/2 cup of sugar and 1 cup of flour. Complete the table to show how much sugar and flour are used in different number of batches for the recipe. So, we need to find the constant proportionality. Remember that from unit 1? So remember to find the constant proportionality, we just go second column divided by first column. So in this case, here's my 2 numbers I'm going to use. Second column, 1 divided by 1/2. So in my calculator, if I go 1 divided by 1 ABC2, using the fraction button, 1 divided by 1/2, I get 2. So my constant of proportionality is 2. Remember, if we go first column to second column, we're going to multiply by 2. And if we go from second column back to first column, we're going to divide by 2. So I'm going to use my calculator because I got lots of fractions here. So 3/4, 3 ABC4 times 2 is 1/2. Okay, 1 3/4, so 1 ABC3 ABC4 divided by 2 is 7/8. 1 times 2 is 2, and then 2 1/2, 2 ABC1 ABC2 divided by 2. So we're going backwards again. It's 1 1/4. Okay, so there you have it. Page 24, 3.2. So it says the price of rope. These 2 students are solving the same problem. At hardware store, they can cut a length of rope off a big roll, so you can buy any length you like. The cost for 6 feet of rope is $7.50. How much would you pay for 50 feet of rope at this rate? So Kieran knows he can solve the problem this way. He sees that he finds the unit rate for 1 foot of rope. So what he does is he multiplies by 1/6. That the book likes to multiply by fractions. I like to divide. So multiplying by 1/6 is the same as dividing by 6. So he divides both by 6. So $7.50 divided by 6 is $1.25. So it's $1.25 for a foot of rope. Though, to get up to 50 feet of rope, we're just going to multiply by 50. So $1.25 times 50, using my calculator, I get $62.50. 62.5. Okay, what would Kieran's answer be? We just did that. All right, Kieran wants to know if there's a more efficient way to solve the problem. Priya says she can solve the problem with only 2 rows in the table. So Priya goes from 6 feet of rope to $7.50, and then 50 feet of rope for blank. What do you think Priya's method is? Go ahead and think about it for a second, then we'll get back to it. So the way I would do this is I would do the same thing as Kieran, but I wouldn't list out all the steps. So I'm going to find the constant proportionality. I'm going to go 7.5, get a pin here, 7.50 divided by 6, and I get $1.25. So then I just go 50 times $1.25, and I still get $62.50. Okay, that's what I would do. All right, so moving on. 3.3. Tyler swims at a constant speed, 5 meters for every 4 seconds. How long does it take him to swim 114 meters? So once again, find the unit rate, or constant proportionality. We're going to go 4 divided by 5. Second column divided by first column, we're going to get 0.8. So then I just have to go 114 times 0.8. So using my calculator, 114 times 0.8, I get 91.2. All right. A factory produces 3 bottles of sparkling water for 8 bottles of plain water. How many bottles of sparkling water does the company produce when it produces 600 bottles of plain water? So we need to fill it out first, and then we need to answer the question. So 3 bottles of sparkling water, so 3 here. 8 bottles of plain water. How many produces for 600 plain? So go ahead and hit pause, try to figure this one out on your own, and then go ahead and hit play to check your answer when you're done. All right, hopefully you figured out the answer. So we find the unit rate. We go 8 divided by 3. So 8 thirds is 2.6666666666. Okay? And then because it's the second number, we're going to divide by 2.6. So we're going to go 600 divided by 2.66666666, and we should get somewhere around 225. If you use the calculator and do 2 2/3, you'll get exactly, my pen turned off, 225. If you go 600 divided by 2.666, you get 225.05, so it's close, right? All right, more problems. A certain shade of blue paint is made by mixing 1.5 quarts of blue paint with 5 quarts of white paint. How much paint will you need with 4 quarts of blue paint? So now they don't give us a table. We got to create our own. So if I move over here, I'm going to create a table here. So we have blue paint and white paint. It really doesn't matter if you put blue or white first. You just got to know second column divided by first. And then if you're going this way, you're going to multiply. If you're going this way, you're going to divide by that constant proportionality. So I put blue first, so 1.5 blue and 5 quarts of white. So I want to know how much I'm going to put with 4 quarts of blue. So in my calculator, I'm going to go second column divided by first column. So I'm going to go 5 divided by 1.5. So 5 divided by 1, ABC1, ABC2. I get 3 1/3. So 3 1/3 is my constant of proportionality. So if I go 3 1/3 times 4, because 4 is in the first column, I get 13 1/3, or 13.33333. Okay? For each of these 3 previous situations, write an equation. So remember, writing an equation, we take the constant of proportionality. Oops. Take the constant proportionality, put it with the first column, and that equals the second column. So if we move back up here, my constant of proportionality is 0.8. So 0.8 times the first column, d for distance, equals the second column, t for time. All right? Here, let's move it up here. So my constant proportionality, 2.666666 times the first column. We'll go S for sparkling water equals P for plain water. And the last one, let's move it over so we can actually see the constant proportionality. 3 1/3, so 3 1/3 times the first column, blue paint, equals the second column, white paint. Okay, so there's your 3 equations. Constant proportionality times the first column equals the second column. All right. All right, looking at 3.4 on page 26, more of the same type of problems. So Lynn runs 2 3/4 miles in 2/5 of an hour. Tyler runs 8 2/3 miles in 4/3 of an hour. How long does it, at this rate, how long does it take them to run 10 miles at this rate? So looking here, they don't want to know how long it takes. Well, they want to know how long it takes, not how far they can go in a certain amount of time. So we're going to divide hours divided by miles. So if I go 2/5 divided by 2 3/4, I get 8/55 if I use my calculator. And that's 8/55 hour to run each mile. So then I just run times that by 10. 8/55 times 10 miles is 1 5/11 of an hour. Okay, and then I do the same thing for Tyler. I'm going to go 4/3 divided by 8 2/3. So using my calculator, if I go 4 ABC3 divided by 8 ABC2 ABC3, I get 2/13. So it takes him 2/13 of an hour. Then we multiply that by 10, and 8 2/13 of an hour times 10 is 1 7/13 of an hour. Okay, so 1 5/11 and 1 7/13. Okay, number 2, you would do the same type of thing. It says Priya mixes 2.5 cups of water with 1/3 cup of orange juice concentrate. Diego mixes 1 2/3 cups of water with 1/4 cups of orange juice concentrate. How much concentrate should they each of them put with 100 cups of water? So we're going to do the same thing. We're going to go 1/3 cup. 1/3 cup divided by 2.5. And if I do that, 1/3 divided by 2.5, I get 0.13333, which is a fraction, is 2/15. Then I just go 2/15 times 100 batches, and I get 13 1/3. Okay. So the main thing with these ones is you got to see what are they asking you to do. So what order do I need to go? Okay. And that is it. So looking at page 26 for the summary, it says if we identify two quantities in a problem and one is proportional to the other, then we can calculate the constant of proportionality and use it to answer the questions about the situation. For example, Andre runs at a constant speed, 5 meters every 2 seconds. How long does it take him to run 91 meters? In this problem, there are two quantities, time and seconds, and distance in meters. Since Andre is running at a constant speed, time is proportional to distance. We can take a table and then figure out the information. So with all these problems, the easiest way is to make a table. Then you know what number, second column divided by first column. And then if you have the number in the first column, you're going to multiply by the constant proportionality. If you know the second number, you're going to divide by the constant proportionality. So make a table, and then second column divided by first column, and then go from there. So looking at your assignment, in the book, we're going to do problems 1 and 3. They're going to be in Canvas, so let's look at those real fast. So number 1, it takes an ant farm 3 days to consume half an apple. At this rate, how many days will it consume 3 apples? So if I make a chart, I have days and I have apples. So 3 days, half an apple. How long is it going to take them to do 3 apples? So once again, second column, 1/2 divided by 3. It's going to give me a number. And then I take that number and I'm going to go 3 divided by that number. 3 divided by that number. And that's going to give me how many days it takes. Okay. Number 3, an airplane flying from New York City to Los Angeles. The distance it travels in miles d is related to the time in t by the equation d equals 0.15 t. So d is distance in miles, t is time in seconds. So how fast is it flying? Okay, well, what's my constant of proportionality? That's going to be the answer to the first question. Well, the constant proportionality is the number in the equation. How far will it go in 30 seconds? So if we're going to go there. So 0.15 times 30, and then how long will it take to go 12.75 miles? Well, that's going to be on the other side of the equation, so we're going to divide by 0.15. Remember, you can always email me if you have any questions.